All right, hello. We got the end of unit review here for trig. We'll go through this pretty quickly and just ask questions. Let me know if anything's confusing. So we're looking here at a water level of a beach, and we have a trig function that we're going to analyze. First question is pretty straightforward. What is the amplitude? Amplitude is just the number that's multiplied right in front there. So the amplitude is 2, and that means that the water goes 2 feet above the midline and 2 feet below. So remember that your amplitude is measured from the midline to the peak and same distance from the midline to the bottom. So another way you could phrase that is you could say that there's like a 4 foot difference between the highest tide and the lowest tide, or you could say it's 2 feet above average at its highest and 2 feet below average at its lowest. So either one of those are correct. All right, next one. What is the period of the function? Remember that the normal period is 2 pi. And this function right here was multiplied by 2 pi over 24 right there. And so when you multiply on the inside of a function, it makes it that many times narrower. Okay, so our period here, we had 2 pi over 24 times our period. I'll just use the letter P. That's going to equal 2 pi, because 2 pi is the normal period. So you always take whatever this number is, 2 pi over 24, and you multiply that by the period to get 2 pi. And so if you solve that, what you can do is divide both sides by 2 pi, which gives you just the number 1 here, and then multiply both sides by 24, and you get that the period is 24. Now that should make a lot of sense, because remember, what are we even talking about? We're talking about the water level. And so the water level is going to roughly repeat every day. It's just 24 hours. It's not perfectly a day in real life because the moon doesn't go perfectly around 24 hours, but that's not important. We're going to pretend it's perfectly 24 hours long. Okay, now it's a sine graph, so I know it starts at 0. It has an amplitude of 2, and the period is 24. So I know it's going to be back here at 24, at 48, and at 72. I also know that sine graphs go from the middle to the top and then back to the middle in half of a period. So it's going to go to the top, to the middle, and then it's going to go to the bottom, to the middle, like this. So we're going to repeat that pattern, which is just there, and I'm going to try to make this, yeah. So this is pretty good graph of what it looks like over 72 hours. Um, yeah. One thing that's weird about this is that it looks like there's a negative y value. That's very silly. What would it mean to have a negative amount of water at the beach? But I'm going to ignore that and move on. All right, number 4, the function f is given by 4 plus 2 sine pi x. The function g is the graph of f translated left by pi over 2. And so that means I know if I'm translating left, I'm going to see a plus pi over 2 inside the parentheses, and translated vertically by negative 1. So I know I'm going to see a minus 1 outside the parentheses. Now I see the plus pi over 2 in a couple different spots. And the tricky thing, though, is that I don't see the minus 1. Well, that's because there was already a 4 outside of the parentheses there. And so then I want to do 4 minus 1. So I know it's one of these answers with a 3. So I can't do this one here. I know it's not this one here because this one has a minus on it. The correct answer is this one, because this takes the existing graph and shifts it left by pi over 2. The answer D does it in the other order, because of the parentheses, this one here would shift it left by pi over 2 first, and then, so like this is the first thing, and then this is the second thing. And so that's out of order. It'd be a shift first and then a stretch. But it didn't tell us to incorporate the stretch of pi into the pi over 2 shift. So we have to do part B here because it follows the order that was given. You can always just try to look at the graphs of each of them and determine which one has shifted the right amount. You don't need to be able to predict it. Okay, what is the period of this function? Like I told you before, you know that whatever number is inside the parentheses multiplied by your period has to be 2 pi. So if you divide both sides by 4 pi, excuse me, you get p as a half. So then we're going to have to sketch the graph of our function here. So p is a half. That means we're going to do a full rotation in a length of a half. And it's a cosine graph, so it starts up at 1. So I know by the time we get to a half, we're going to be back at 1. 4/8 is the same as a half. When I get to 1, I'll get back up to 1. Halfway through a full rotation, I'm going to be at the bottom. That's how cosine works. Halfway, once you've got the top half, imagine the unit circle. As you go all the way over here, that's a half rotation. Your cosine value was positive 1, then it's negative 1. And so that's what this arc means. That's a really crappy arc. From positive 1 to negative 1 is half a rotation. Let me make that a little bit better, because it's also going to go through 0 in half of that time. So it should be more like this. There we go. And then it goes like this. So remember, you can go top, middle, bottom, middle, evenly spaced. Middle, bottom, middle, like that. That's a graph. So I always try to think top, middle, bottom, middle for cosine. Okay, now we're talking about a bicycle wheel. Vertical position is represented by this lovely looking function right here. So 13.5 is the amplitude, 20 is the midline, and 5 is part of our frequency. So let's use that real quick. Like we just did in the previous problem, 5 times 2 pi times p equals 2 pi. Divide both sides by 2 pi. Let's just do it in 2 steps. So I have 5 times p is 1. Divide by 5, so p is 1/5. So 13.5 is the amplitude of your wave. And that's the same thing as the radius of the tire. Can you let them in? So the radius of the tire is 13.5. The 5 turns out to mean 1/5. So that means it does 5 rotations per second. And then the 20 is the height of the center of the wheel. Oh, see, thank you. All right, getting through it. Here is the graph of a trigonometric function. Which equation could define this function? First thing I always do is go through the midline, because once I've got the midline, the rest of it falls into place. I guess it looks like 4, -4. Yeah, that looks good. Now I can find from there the amplitude. So it looks like it's 1.5 steps higher or 1.5 steps lower. And the last thing I do is I look at, does it start on the midline? Because sine goes from the midline to the top. Or does it start above the midline? So it starts above the midline, so I know it's a cosine graph. So this one right here is the correct one. Start with the midline and then go from there. Oops, what did I do? There you go. All right, select all the functions that have a period of pi. Now, a period of pi, what does that mean? That means that, remember earlier we were doing like whatever number was inside the function times pi, the period equals 2 pi. Here, we're going to do our b value times pi equals 2 pi. That means our b value is just equal to 2. So these two dudes have a period of 2 pi. Or sorry, have a period of 1 pi. This has a period of 2 pi. These have a period of 4 pi. All right, almost done. We're matching the expressions with the graphs. This is going to be a little bit annoying because of the formatting here. So I've got, let's see if I can just write them up here. 3 cosine minus 2, 2 cosine minus 3, 3 sine minus 2, 2 sine minus 3. It should stick with me as I scoot up. Almost. Well, that didn't work. That's okay. So I'll just write what all the functions are. So this one has a midline of -3, so I know it's something minus 3. It starts on the midline, so I know it's a sine of theta. And it has an amplitude of 2, so I know it's a 2 sine theta minus 3. I don't need multiple choice. Midline here is -2. Amplitude is 3. Starts above the midline. Okay. Then let's go down to graphs 3 and 4. Let's see. Midline of -2. Amplitude of 3. Starts on the midline. See, it's just those 3 questions you got to ask yourself. The only other thing that would happen here is if the period was different, then we'd have a number multiplying on the inside. But all of these have a period of 2 pi. So I'm not worrying about the inside thing. I'm just worrying about what's the midline, what's the amplitude, and is it a sine or a cosine graph. Same idea here. Midline -3 starts above the midline, starts 2 steps above the midline. So there we go. All right, here's the graph of a trigonometric function. What equation does the graph represent? Tricky here because this one has a y-intercept it's not the midline, and it's not the peak either, so that's a little tricky. But I do notice that the amplitude is 2, and I do notice that if I look at the point pi over 4, that it's at its peak. So if I see this as a graph that has been shifted, then I can think of this as a cosine graph. And I can think of it as a 2 cosine graph because it starts 2 steps above the midline. And it's just been shifted pi over 4 to the right from what the original cosine would look like. So there we go. All right, almost there. Here's a graph of the equation. Wonderful. Indicate the midline on the graph. We've already talked about this, so it's y equals -3. Use the graph to find the amplitude. The amplitude is 2. Almost done. Indicate the amplitude and the midline. So we've done this quite a bit. A equals 2. The midline is y equals 0. On part B, A equals 1. The midline is y equals -5. Part C, A equals 1.4. The midline is y equals 3.5. And that does it. Let me know what you need help with. Happy to explain it more.